So we're going to go ahead and begin looking over this formula, see what you guys came up with. Starting with the first one, A, we want to evaluate log base 3 of 81. So we're looking for the exponent. 3 to the power of what gives you 81? 4. 3 to the power of 4 gives you 81. Okay. Log base 5 of 1 over 125. Remember that to get a fraction, your exponent must be negative. In this case, what is our answer? Negative 3. 5 to the negative 3 power. All right. Before I move on from A and B, I just want to make sure that you guys understand this part. If you are having trouble with a logarithm, it's always a good idea to go from logarithmic form to exponential form. That might make more sense. For example, if I want to switch logarithm to exponential, I would rewrite this problem as 3 to the question mark equals 81. And so we can clearly tell that the question mark needs to equal 4 in this case. Same thing with log base 5 of 1 over 125. This is asking you, well, 5 to the power of what gives you 1 over 125. Okay, in this case, we can tell that it's negative 3. Now, looking at log base 49 of 7, if we were to rewrite this as a exponential statement, we would say 49 to the what power gives you 7. And so this is when things start to get tricky, because you're going from a big number to a small number, and this small number is not a fraction, so it's not a negative exponent. It's also not a whole number exponent, because if it were a whole number exponent, we would get something bigger than 49. So that leaves us with very limited choices here. Now, it's probably easier if we think about it in terms of like how many times does 7 go into 49? Like how many times do you need to multiply 7 times itself to get 49? Because that's going to give you part of the solution here. So 7 times itself, like how many groups of the same size would I need to get to 49? In this case, I would need 2 groups of the same size, right? I would need the 7, which is one group, and I would need another 7 to get to 49. But because this problem only displays one of these 7s, then what we're saying is that we want one of the 2 7s that we were given. And so what ends up happening is we're saying, okay, 49 was actually raised to the 1/2 power, and that is how we got our answer of 7. Now, once again, if you didn't catch that, let me re-explain where the fraction came from. We're saying there were 2 equal-sized groups of 7, because 7 times 7 is 49. But because the number in the parentheses is only one of those 7s, we are told that we only chose one of the 7s from the 2 that are there. And that is how we get the 1/2 power. 1 represents the 1 7 that we started with. 2 represents the 2 7s that are needed to get to 49. Okay? And so this answer is 1/2. It's a fractional exponent. I know I don't know if, well, obviously I think I'm the only one that taught you fractional exponents, but there are other ways of looking at fractional exponents. Sometimes you relate them to square roots or roots. We didn't teach you guys that this semester, but it is something that if you were to move on to another class and they teach it to you that way, it's something that could also make sense, right? 49 to the 1/2 is basically saying what is the square root of 49. That might make more sense in this case, but yeah. All right, so moving on to the next one. So by the way, the solution was 1/2. Moving on to the next one. I had you guys double check on page 11, because on page 11 is where we were switching back from exponential to logarithmic form. So all that you need to do in this case is you just need to correctly identify what the base is, what the exponent is, and what your answer will be. Because based on that, we can rewrite the statement. For example, we know that our base is 3. So 3 will get raised to the power that I have identified as my exponent. In this case, 3 will get raised to the m power. And that's going to result in everything that is inside of the parentheses. So the statement converts to 3 to the m equals x minus 5. Okay? All right. Going the other way, starting with exponential going to logarithmic, it's the same case. You need to identify the base, identify your answer, and identify your exponent. Now, we start out by writing log first, regardless of what the base is. So we write the word log first. And then, of the three things we've identified, we want to pick the base. Log base, what's the base? 5, log base 5, so little number is 5. Log base 5 of your answer, log base 5 of n minus 8 equals the exponent. So we end up getting this statement here, log base 5 of n minus 8 equals x plus 4. Okay. All right, so in today's lesson, we are strictly going to focus on solving exponential and logarithmic functions using algebra. So it's more of an algebraic approach. It's going to require us to switch forms. Whatever form you're given, you want to use the opposite form. For example, if we start with exponential form, we want to switch to logarithmic form. If we start with logarithmic form, we want to switch to exponential. Now, like I said, a lot of the work today is going to be solving for x. It's going to require us to use a calculator, so I'm going to ask that at this time you send one person from your group to grab calculators for everybody at your table. Go ahead and take care of that. I'm going to give you guys about a minute to get that taken care of so that I can move on to the next section. Let me go ahead and read the following to you guys. Here are the guided notes. Solving an exponential equation will involve rewriting the equation in logarithmic form, and vice versa. If you start with a logarithm, you want to rewrite it as an exponential. You always want to give an exact answer. By the way, just so you know what an exact answer looks like and what constitutes as an exact answer, anything that you get from your calculator, any answer that you get from here is not an exact answer. Anything that you round or get from a calculator is known as an approximate answer. Okay. So let's take a look at the first one, number 4. Let's solve for x. 5 to the x equals 28. First, you want to identify what form you're starting with. For us, we are starting in exponential form. So I need to go from exponential to what? Logarithm. Exponential to logarithmic. How do I do that? Well, we did in the warm-up, right? We said first identify the base, identify your answer, and then identify your exponent. All right, so let's write our statement. This will become the following. Log base 5 is my base, log base 5 of 28 equals x. Okay? Log base 5 of 28 equals x. Now, this right here is what we consider the exact answer. Okay? Once again, this right here is what we consider the exact answer. However, I'm going to have you guys go a step further and actually find the approximate answer. So how do I do that? Turn on your calculator. I'm going to have you do the following steps. You're going to hit the math key underneath the green key. There's a green alpha key. So hit the math key. It's going to open a bunch of options for you. All right, please make sure that you are doing this. I see some of you guys not doing this yet. Once again, turn on your calculator, hit the math key. All right, you're going to hit the up key twice, arrow up 2 times, until you see the feature or the option of log base. Log base should be highlighted. Does everyone see that? All right, hit enter. It's going to open up a menu. It's going to open up a function. It's going to say log base blank of blank. The little box, you're going to type a 5 in there, and the bigger box, you're going to type a 28. And then you're going to hit enter. Now, if you did this correctly, you should get the following solution. You should get 2.070415071. That's a big number, right? Or not a big number, but a lot of numbers. Now, let's read that last statement that last bullet point says the following. Use a calculator to give an approximate answer and keywords. Round to the nearest hundredth. So, we are going to round this number, 2.0704, to the nearest hundredth. Let's take a look at what that looks like. By the way, whenever you write your approximate answer, you are not using the equal sign. Equal only gets used for exact answers. For approximate answers, you use the squigglies like this. This represents approximately. X is approximately equal to. Now, we said this was 2.0704 and a bunch of other stuff, right? If I'm rounding to the nearest hundredth, the hundredths place is the second digit after the decimal. So I'm looking at 7. To determine if 7 will get rounded up or down, you need to look to the number on the right. If that number on the right is 5 or more, we round the 7 up to an 8. If it's not 5 or more, meaning if it's less than 5, we drop all the numbers after the 7. Now look, I just pointed to it. The number after the 7 is a what? 0. Is 0 bigger than 5? No. 0 is less than 5. So we're going to drop all the numbers after the 7. This is what your solution will look like. You will get x is approximately equal to 2.07. This is your approximate answer. Make sure that you are able to differentiate between what's something that's approximate and something that's an exact answer. On the test, I'm not sure if it's on this test, but there is a test where we will not give you access to a calculator and we'll ask for exact answers. So we want you to leave your work like this, where you just simply solve for x. We don't want you to give us an approximate answer. So pay special attention to that. I'll leave number 4 on the board. I want you guys to try number 5. Please do so at this time. All right, so number 5, 50 equals 7x. Who can tell me what this looks like as a logarithm? When I switch 50 equals 7x to a logarithm, what will I get? Log base what? Log base 7 of 50 equals x. This is your exact answer. Okay? Log base 7 of 50 equals x. Let's go ahead and solve this, put in the calculator to get our approximate answer. If you haven't already, please do it at this time. Type in log base 7 of 50 into your calculator. And once you have it, just give me a thumbs up. Okay. Log base 7 of 50. All right, who can give me the rounded solution? What is the rounded answer? Dylan, go ahead. 2.01. That's our approximate answer. Okay. All right, any questions on number 5? Okay, let me show you number 6 now. So, usually when you go from logarithm to exponential, you're more likely to get whole numbers. It's only when you start with exponential and go to logarithm that you'll get like approximate answers. Let me show you what that looks like. So, log base 4 of 2x equals 3. I can rewrite this. This, by the way, is in logarithmic form. And we're going to change that to exponential. So we turn log base 4 of 2x equals 3 to the following. 4 to the third power equals 2x. We can simplify 4 to the third power to 64. 64 equals 2x. We're trying to get x by itself, so what should my last step be? Divide both sides by 2. 32 equals x. That's an exact answer, okay? Exact answer. Go ahead and try the next one on your own, please. Try number 7 on your own. So, log base 3 of x minus 2 equals 4. How do I rewrite this? This will become 3 to the power of what? 3 to the power of 4 equals x minus 2. All right, 3 to the 4th power is 81. 81 equals x minus 2. Add the 2 to the other side. 83 equals x. Give me a thumbs up if you got 83. All right, good work, everybody. So, let's move on to something a little more challenging now. All right? Want to make things a little bit easier for us. I mean, a little bit harder for us. A little harder, a little harder. Okay, 3 to the 2x equals 92. Let's do it. This is exponential. We want to switch to logarithm. So this becomes the following. Log base 3 of 92 equals 2x. Now remember, we want to get our exact answer. So right now, x is not by itself. X is being multiplied with a 2. So I want to get rid of that 2. How would I do so? I would divide it out. Divide both sides by 2. So I get the following statement. X equals log base 3 of 92 over 2. Okay? Once again, x equals log base 3 of 92 over 2. This is your exact answer. Let's take it a step further and find the approximate answer. So, let me show you how to put this in a calculator because now there's that extra step. You're going to go to, first of all, go to the left parentheses and hit left parentheses. So that way you have like a numerator and then slash denominator. So you hit the left parentheses, which is underneath the cosine, COS symbol. Once you have that, you're going to go to math, go 2 arrows up, hit enter. So you'll have left parentheses followed by log. You're going to type in log base 3 of 92. And then you're going to hit the arrow over. So you're like outside of the parentheses from the log. And you're going to hit right parentheses this time. So you'll have like 2 parentheses at the very end. You'll have 2 right parentheses. One of them is the right parentheses for the logarithm, and then one is to like finalize that statement. Once you have that, you're going to hit the divide symbol and then a 2. And so we're doing the parentheses just to make sure that the calculator knows that the numerator is log base 3 of 92, and then the denominator is separate. If you hit enter, you should get the following number, 2.057954669. Give me a thumbs up if you got that number. Watch. Start with left parentheses. Left parentheses, math, log base. Oh. Where's it at? Log base 3 of 92, and parentheses divide by 2. Okay, so let's round this number. 2.0579. 2.057. We're looking at the 7. That's going to become 2.06. Approximate answer is 2.06. Good. I'm not saying you're going to get it wrong if you do it the normal way. I'm just letting you guys know how to do it this like other way, because when you put the parentheses, it's like really telling the calculator, hey, this is separate. Like this is only a numerator. For some features, if you just put divide by 2, it's not going to read it correctly. That's why. All right, try out number 9 on your own. 3 to the 4x equals 75 becomes the following. Log base 3 of 75 equals 4x. Divide both sides by 4. X equals log base 3 of 75 divided by 4. This is going to equal approximately what? When you put in the calculator, once again, don't forget to do the parentheses. Parentheses, log base 3 of 75, and parentheses, and then divide by 4. Who can tell me what they got for this one? Yeah, Aiden, go ahead. 0.98. Good. That is the approximate answer. 0.98. So remember that after the 8, you have a 2. Because that 2 is less than 5, we drop everything after the 8. All right. Let me show you how to do number 10. And then you'll try 11 on your own. So log base 4 of x over 2 plus 3 equals 2. This is logarithm going to exponential. So this will become 4 to the second power equals x over 2 plus 3. 4 to the second power is equal to 16. So you have 16 equals x over 2 plus 3. You're going to subtract the 3 from both sides. That will give you 13 equals x over 2. To cancel, to get rid of that dividing by 2, you're going to multiply both sides by 2. So you get the following solution, x equals 26. Try the next one on your own, please. Okay, 2 equals log base 3 of 2x minus 5. So going from log to exponential, we start with base 3. 3 to the second power equals 2x minus 5. 3 squared is 9. 9 equals 2x minus 5. Add the 5 to both sides. 14 equals 2x. Divide by 2 on both sides, and you find that x equals 7. Give me a thumbs up if you got x equals 7. Awesome. All right. I'm going to show you 2 more examples, and that'll be it. The rest of class, you will have to finish some of the questions on your own and finish your practice. All right. So let's look at number 10. I'm sorry, number 12. This is going to have a few more steps, so I'm going to try and go slowly. Please do your best to follow along. Be mindful of side conversations to pay full attention of what's going on, right? So here we're starting from an exponential form, and we want to go to logarithm. But before we do that, we can't just switch from exponential to logarithm without cleaning this up. What do I mean by that? So you have a negative 7 right there that we need to add to the other side. This becomes 2 parentheses 4.5 to the x plus 3 equals 70. All right. Next, we would divide both sides by 2. So all of this, I'm just like removing the stuff that's around the exponential. This is going to get me 4.5 to the x plus 3 power equal to 35. I'll kind of stop there, give you guys some time to catch up. All right, now that we actually have it strictly in exponential form with no coefficients, nothing being added or subtracted, now we can actually switch from exponential to logarithm. So this will become the following. Log base 4.5 of 35 equals x plus 3. And we just have one little thing left to do to get x fully by itself, and that is to subtract 3. So we're going to subtract 3, and then subtract 3 from all of that. So we get the following. X equals log base 4.5 of 35 minus 3. And that's going to give us our exact answer. We still need to do the approximate answer. But I'll let you guys catch up with that line. Please write that line down. Okay. And then we can go ahead and try putting this into the calculator. Go to math. Open log base 4.5 of 35 minus 3. It's going to give you the following number. It's going to give you negative 0.636. Since we run into the nearest hundredth, we look at the third digit, which is a 6. So this will get rounded up to the next number over. Negative 0.64 will be our approximate solution. Okay. All right, so this right here is exact. This right here is approximate. Okay. All right. Let me show you one last example, and then we'll probably take a break at that point. That way when we come back, we strictly focus on finishing the rest of this. All right. So let's look at 13. Log base 3 of x minus 7 over 2 minus 6. Begin by adding 6. That'll be your first step. Add 6 to both sides. You'll get log base 3 of x minus 7 over 2 equals 1. Once again, log base 3 of x minus 7 over 2 equals 1. Multiply both sides by 2 to cancel out the 2 that's underneath. Log base 3 of x minus 7 is equal to 2. At this point, we can switch from logarithm to exponential. 3 squared equals x minus 7. Three squared is 9. 9 equals x minus 7. $16 is equal to x. And so that's how we get our answer. All right. So you'll find that it might be easier when you start in logarithmic form and go to exponential than going from exponential to logarithmic. In any case, we'll take a break now, come back in about 10 minutes, and then we'll finish the rest of this.